Here's the third part of my science project, and it is on transportation. So, what I'm going to talk about is transportation, as I said, but there are two types of transportation, and there is the passive transportation and the active transportation. No, I mean passive transport and active transport, not transportation. Scratch that. So, what this transport does is it's a process where the resources can enter the cell membrane, and there are different kinds of how that happens. Different ways of how that happens, not kinds. So, there is one way, which is the process of diffusion. So, what happens in diffusion is that a resource that is in higher concentration goes to a lower concentration. So, as you can see, the inside of the cell is almost empty, except for for those chickens that are coming right now. So it's quite empty, and there is quite a lot of chickens and cows outside the cell. Now, these animals are representing the resources. So don't think that there are going to be chickens and cows walking around inside a cell. So to demonstrate how they diffuse to the inside of the cell, I can enable their passage, and you will soon see that the cell is going to hopefully fill up with chickens and cows. As you can see, I'm getting quite a lot of cows, and chickens are going there as well, because there are a few chickens inside the cell, so they have a tendency to go where there are less chickens or other animals. And that's the same thing with the resources. If you have a lot of resources outside the cell, then it slowly diffuses to the inside of the cell, and it becomes in equal concentrations, both inside the cell and outside the cell. But some resources are too big to pass through it. So there is this carrier protein, which is represented by this block, and as you can see, the cows are too big to pass through the membrane. So there are these carrier proteins where they can pass through, and as you can see, it just got passed over there, and that is called what was it? Facilitated diffusion. Yeah. So facilitated diffusion is when the bigger resources have to get passed to the membrane, but they can't. So there's this carrier protein that helps them to do so. Now over here we have an example of active transport. So you can see there are the chickens or resources outside the cell, and inside the cell there are none. So slowly the chickens will diffuse into the cell. But what if the cell needs more nutrients than it's getting just by diffusion? That's where active transport comes in, and it requires the cell energy. So whenever it uses active transport, it's using energy. And what it does is it takes the resources and gets them inside the cell, or makes the balance between it makes the concentration between the outside and the inside of the cell unbalanced. So the concentration inside the cell now is higher than the concentration inside the cell, probably. Well, maybe not inside the cell, but like around it. You can notice that the chickens are being pushed towards the cell, and it's the same thing with the active transport in cells. The cell takes more resources into it if it's not getting enough by diffusion. So that's how it works. And now there is the osmosis part. Now I'm going to talk about osmosis, which is when the concentration of water goes from high concentration to low. So as you can see here, there's a high concentration of water inside the cell. I'll say that the left side is the inside of the cell, and the right side is the outside of the cell, which doesn't have as much water. So what happens is that naturally the water crosses the membrane and becomes the same level as of the outside. So the concentrations become the same, basically. So as you can see, you just open the barrier, so you can see that the water from the inside the cell is becoming in the same concentration level as the water outside the cell, but this can be in reverse as well. The left can be the outside of the cell and the right can be the inside, but it doesn't really matter. What matters is that the water from a high concentration of solubles can go from a high concentration can go to a low concentration. So you saw that now it's equal or near to equal, and over here we have particles in the inside of the cell, and the water is clear outside of the cell. So what happens? The concentration of water inside the cell is lower than the concentration of water outside the cell. So instead of the sides staying equal the way they are, the water actually decreases on the outside of the cell and increases on the left side of the cell. Or I got that wrong. So it decreases on the outside of the cell and increases the water volume inside of the cell. So the concentrations can be the same. So right now you can see that the level of water over here has lowered, and over there it has the water level rose. So that's how osmosis works, and that's the end of my project.